Hi, my dear students. I'm welcoming you all to my next video on surface chemistry. Can you see something on the screen? What is this?
Wow, it's a rainbow!
And this is how the kids get excited when they see a rainbow. But according to chemists, it is called as a continuous spectra. Do you all know how this is going to happen? I've seen the path of the light in the movie hall. Can you guess why this is happening every time when you go out for watching a movie? Nice thick forest, isn't it, students? But have you all noticed the behavior of light? Why there are a lot of splits in the light? Is there any science behind all the picture I have shown you now? Keep thinking. In the meanwhile, I'll step into a surface chemistry very slowly. Students, what is solution? Solution is a homogeneous mixture of solvent and solute. Now there may be a question, what is solvent? Solvent is any substance which is present in larger quantity or the one which does the dissolving is called as a solvent. But at the same time, what is solute? Solute is one which is present in smaller quantity or the substance which gets dissolved in the solvent is called as solute. For example, if you have a glass of water, you are trying to dissolve 1 tablespoon of sugar. Sugar serves the purpose of solute since it is in a smaller quantity, whereas water, which is present in a larger quantity, going to serve as a solvent. And when you mix these two, what you are going to end up is called as solution. For the purpose of this topic, solutions are further classified into 3 types. One is true solution, suspension, and colloids. Now, let us try a small activity to understand what is this true solution, colloids, and suspension. Here is a kid who is going to perform the activity for us. He has taken same amount of water in 3 different beakers. For the first one, he is adding a sugar. For the second beaker, he is adding a chalk paste powder. Let us watch what he is going to add for the third beaker. He is adding milk. Now he is watching all the beakers keenly. Now the kid is trying to dissolve all the content by stirring one by one. Oh, the power has gone. Bad time for a kid. But he has got a torch. Now he is directing a beam of light on beaker number 1. Sugar has got completely dissolved. If any of your solution looks like this, it is called homogeneous solution, meaning it has a uniform distribution. After dissolution, sugar is not visible to our mere eyes because it has a size less than 1 nanometer. Then another thing is that where is the path of the light? It is not visible. Let us watch what is happening with the second beaker, in which particles of chalk paste can be easily seen with the naked eyes. Since these are insoluble, this is called heterogeneous mixture. That means non-uniform distribution. Moreover, when the beam of light is passed through this beaker, it scatters light. That is, path of light is visible. The phenomenon of scattering of light is called Tyndall effect. However, after some time, all chalk paste particles settle down since they are looking heavy with the size greater than 1000 nanometer. This kind of mixture is called as suspension. In suspension, after certain period of time, Tyndall effect cannot be seen. Let us have a look at the third beaker. Path of the light is clearly visible. That is, scattering of light is happening. In turn, Tyndall effect is seen. Mixture looks like homogeneous. Let us watch it through a high resolution microscope. Surprise! It is heterogeneous. This kind of mixture is called colloid. It has a particle size between 1 nanometer and 1000 nanometer. In colloidal particles, settling down never occurs. Hence, Tyndall effect can be seen throughout in a colloid. For today, we are going to explore colloids. Under this roof, we have colloids and classification of colloids, preparation of colloids, purification of colloids, emulsion, and application of colloids. From the activity, we have come to know that suspension and true solutions are extreme corners, and the one which falls in between is called colloidal solution, otherwise simply say colloid. The size of suspension is greater than 1000 nanometer, whereas the true solution has a size less than 1 nanometer. 1 nanometer. While the colloidal solution falls between these two, that is, it has a size between 1 nanometer to 1000 nanometer. Let us analyze the rest of the properties of these three solutions through the next slide. Here, three different types of solutions which we have seen through the activity are discussed. The first one is nature. If you look at the nature of suspension, it is heterogeneous. That is very clear from the activity. But colloid's heterogeneous nature can be seen only using a microscope. We need a microscope to see the heterogeneousness of colloid. And then true solution is homogeneous to the mere eye as well as to the microscope. The particle size is greater than 1000 nanometer in case of suspension, but in the case of colloid, as I was telling you, it falls between 1 nanometer to 1000 nanometer. But true solutions are too small and its size is less than 1 nanometer. Now the question is, can we separate them? You just assume you are in the lab and you are detecting a salt which contains chloride radical. The confirmation test what we do for a chloride detection is AgNO3 test. Now you tell me an answer. During this test, AgCl precipitate is formed. can we filter that using a normal filter paper? The answer is going to be yes. Hence, the suspension can be filtered with the normal filter papers as well as through the ultra filter papers. Colloids cannot be separated through the ordinary filter papers, but it can be filtered only through the ultra filters. In the case of true solutions, it is not possible using a ordinary filter paper as well as through the ultra filter paper. Settling of particles. Suspension is heavier when you make a comparison to other two solutions or say mixtures. Hence, just under the gravity they used to get settled. But for a colloid, we need a special technique called centrifugation. Only under centrifugation they get settled, whereas true solutions cannot be settled at all. I was telling you about Tyndall effect. Tyndall effect is scattering of light by a colloidal particles. Suspension shows that, but after some time you may not be able to see. You can see a Tyndall effect in suspension until they settle. After that you may not be able to see it. But in colloids you can see a Tyndall effect forever. But in the case of true solution, you cannot see a Tyndall effect at all. Phases of colloid. Now, all of us know that colloid is a heterogeneous mixture. Means it should have two components in it. The first one is dispersion medium or continuous phase. The second one is dispersed phase or discontinuous phase. Let us check them one by one. The first one is dispersion medium or continuous phase. It means that it is a component which is present in excess, just like a solvent in a solution. For example, assume we have a silver salt which is prepared in water. So silver will be spread in a water like this. It means that silver will be a dispersion phase and water is going to be a dispersion medium. Let us analyze dispersion phase again through the next slide. The second one is dispersion phase. Dispersion phase is a component present in a smaller proportion. Otherwise, it is going to behave like a solute which we have discussed in the solution. If you can consider a silver salt in water, the silver will be spread like this and water will be continuous. This indicates that silver is a dispersion phase and water is going to be a dispersion medium. Students, let us study the classification of colloids. There are various classifications for colloids. The first one is based on the physical state of a dispersed phase and a dispersion medium. Before we try understanding this, please be very clear with these two terms which are here. Dispersed phase is like a solute present in smaller quantity, whereas dispersion medium is like a solvent which is present in larger quantity. By keeping this as a key, colloids are of various types. Now, if the smaller portion is a gas and the larger portion is a liquid, it is called as foam. and foam can be seen in soap lather while whipping a cream or any kind of froth is considered to be a foam. If the dispersed phase is a gas and the dispersion medium is a solid, it is called solid foam. And for this, the examples are cake and few baked products such as bread. And very common example is pumice stone. Liquid and gas is called aerosol. This can be found in mist, fog, and clouds. Liquid and liquid is a very famous type of colloid, and we'll be studying this in detail at the later part of the topic. It is called emulsion. Milk, cream are an example for emulsion. Liquid and solid is called gel. Examples: curd, cheese, jellies, polish, butter, etc. Solid and gas is called solid aerosol. Example: smoke and dust. Solid and liquid, again a very common colloid called sols. Examples are paints, cell fluids, and inks. Solid and solid is called solid sol. Example: colored glasses, gemstones. To check our grip on this classification, let us take some example and analyze to which kind of colloid all this belong to. So try it by your own. Here are some important points to remember. The first one is gas in gas doesn't form a colloid because gas in gas always forms a homogeneous mixture. The most common colloids are salts, that is solid in liquid, gel, that is liquid in solid, and emulsion, that is liquid in liquid. If the dispersion medium is water, the colloid is called as aquasol or hydrosol. In case if the solvent is alcohol, it should be called as alkosol. This classification of colloids is based on the nature of interaction between dispersed phase and dispersion medium. What is this actually? Assume this is a colloidal solution and the colloid is present in a water. You all know that colloid is a heterogeneous mixture. It contains dispersed phase and dispersion medium. Now, this classification concentrates on if you have water as a dispersion medium and some colloidal particle here as dispersed phase, do they interact or not? Based on this key factor, colloids are further classified into two types. One is lyophilic colloid, second one is lyophobic colloid. In a word lyophilic, lyo stands for solvent and then philic stands for loving. Philic stands for loving. This word itself very clearly indicating that there is going to be a huge attraction between the dispersed phase and the dispersion medium. Whereas in the other one called lyophobic, the word lyophobic indicates solvent hating. From this, it is very clear that there is going to be no attraction between dispersed phase and the dispersion medium. Is there any differences apart from this affinity? If you check out, there are many differences between lyophilic and lyophobic. So the first one you are quite aware of now. They have a great affinity, but they have no affinity or less affinity for the dispersion medium. Lyophilic salts are reversible, but lyophobic are irreversible. Lyophilic salts are more stable due to the interaction between the medium and the phase, but this is less stable. Lyophobic salts can be prepared very easily, but lyophobic salts, we need special methods such as Briggs arc method, chemical methods, etc. In lyophilic colloids, extensive hydration takes place, but here there is no hydration. The next difference is lyophilic salts cannot be coagulated easily, but lyophobic salts, just by adding a small amount of electrolyte or by heating or by shaking, we can destroy them. Otherwise, we can precipitate them very, very easily. The surface tension of a dispersion medium in lyophilic salt is lower than it was earlier. But in the case of lyophobic salt, the surface tension remains the same. Viscosity is much higher due to the interaction, whereas in this case, viscosity is remaining same. Examples for lyophobic salts are gum, gelatin, starch, protein, polymer. All are an example for lyophilic salts. Whereas an example for lyophobic salt is metal salts such as silver salt, gold salt, platinum salt, metal hydroxides, metal sulfides.